Okay, to find out when this function, x to the minus x, is increasing and or decreasing, we're going to have to find the first derivative and apply the first derivative test, which will also lead us to finding possible local maximums and minimums. So here I said y equals x to the minus x. X has to be greater than 0 because we don't want this base to be negative. We're going to use logarithmic differentiation, so we're taking the natural log of both sides. And this can be rewritten as minus x ln of x using properties of logarithms. That's the whole point. Now when we take the derivative, this will be, the left side will become y prime over y, where y prime is like the derivative of the inside, y is a function of x. And then over here, we have to use the product rule. I like to say first function times the derivative of the second plus the second function, ln of x, times the derivative of the first, which is minus 1. Simplifying that, we get minus 1 minus ln of x. And now to get y prime by itself, we multiply both sides by y. And that's what this is right here, x to the minus x. Okay, now, so we want to know when does this first derivative equal 0, finding the critical numbers. Well, this is the product of two expressions giving a result of 0, so one of them has to equal 0, either this one or this one. This one will never equal 0. So we're really only interested in when will this equal 0. ln of x equals minus 1. That means x equals e to the minus 1, moving to exponential form. And that's the same as 1 over e. Now, to apply the first derivative test, we say, well, here's the critical number, 1 over e. We're only dealing with numbers to the right of 0. So we want to find out what's the sign of the first derivative in these two separate intervals on either side of 1 over e. I used a calculator to do this. F prime of 0.2 is positive. You could put 0.2 in here, and you'll get a positive number. That tells us that the original function is increasing. F prime of 0.4 to the other side of 1 over e, which, by the way, 1 over e is about 0.37, is negative. So to the right of 1 over e, the original function is decreasing. That tells us we went from increasing to decreasing. We have a relative max at 1 over e f of 1 over e. And here's what that looks like. There's the graph of f of x. This value is 1 over e, and this is f of 1 over e. Okay, so we needed to use logarithmic differentiation to get the derivative because we have a variable raised to an exponent that also contains the variable. There you go. Hope that helped. If you have any questions, post a comment.